Captain Coder at the helm. Bean water is ready. Today we will learn a lot. He loves the questions, he loves to sing. Join our Discord and follow him.
Good morning, good afternoon, good evening to you, wherever you happen to be in the world. I hope you're having a beautiful day. Captain Cody here on the beautiful day today. It's the 20th of December. We've been in December for 19 days have come and gone. We're on the 20th day. What is happening? Why does time move so fast, folks? It's so nice to have all you beautiful people here on this beautiful day for this beautiful stream. I hope you're out there having a beautiful day, folks. Thank you guys so much for being here. We got the whole crew with us. We got everybody. It's amazing to have all of you beautiful people out here. I want to say, Sigian, thank you so much for being here so early. I'm so sorry you missed the exclamation point first. Robbed by Clayman. Robbed by Clayman. How could you do that to Sigian? Clayman, how could you do that to Sigian? Poor Sigian over there doing their best to try and get that first every day, and Clayman comes and boom, takes it. Boom, takes it. Boom, takes it. Clayman doesn't even say hello before boom, first got it. Meanwhile, Sigian's doing the best. It's good to see you too, Clayman. I hope you're having a beautiful day. Spoof, welcome back to the stream. I hope you are having a beautiful day as well. It's so nice to see you. How many have you done of these puzzles? How many have you managed to get under 1 millisecond? I know that was your goal initially. Look, if I get under 60 seconds, I'm pretty happy. I'm not even close on that. Mary Cat. I hope it's Mary Cat. Mary Cat. Mary. Oh, Mary. Welcome back to the stream. It's nice to have you here with us on this beautiful day, Mary. I hope you're doing well. It's great to see you again. And Kavadra Tisk, I can't wait for you to heckle me some more today. I always love your heckling. It's always in good taste. Always in good taste. Nice to have you here. And G, enjoy your lunch, my friend. I hope you have a delicious lunch. I hope it's wonderful. I hope it's good. What did I didn't eat lunch yesterday. I had a giant breakfast. So is that like 11 a.m. though? So I guess that it's kind of a lunch brunch, but oh man, I had the best breakfast. It was 3 eggs, bacon, rye toast. But they were cooked to perfection. And then one pancake, and then my girlfriend, she had a little bit of biscuits and gravy. So I just got a few bites of biscuits and gravy. Oh, it was so good. It was so good. We had to, and we didn't finish. I'm so upset. We got to go back today, but luckily I'll be able to stream today. We scheduled him to go later at the house that we lived at before now. We have an inspection on Thursday. So I have had people come to like do a full big ol' cleaning of it, get it all spot fresh, spot clean, so fresh and so clean, so nice and so perfect. And they were there. And they were kind of terrible. They were there for like 5 hours, and at the end of it, I was like walking. They were like, "All right, can you check it out? How do we do?" I was like, "Everything's still dirty." I couldn't believe how much time they spent there. And then it was like they didn't use any cleaning products or something. I don't know, but I could touch surfaces, and they still had like grime and stuff because the house had been sitting there for like 30 days, empty. So you have dust and stuff settling. It was crazy. I couldn't believe it. So we had to get some. I'm gonna have to go back today to finish up. Anyway, that was rough. That was a rough day. Yesterday was a long day. I felt like I was babysitting cleaners. Anyway, what are we doing today, folks? I'm gonna stop rambling. City says time to write a bot to earn points for exclamation point first. Let's check which host and provider is faster. Yeah, Sigian, do it. Yeah, Sigian, I don't know if you noticed there's a bug in the first. If you can just keep doing it over and over and claiming more points. This was discovered by JD. Yeah, there's a bug. Oh, I forgot we got 2 new followers. Got Ska Walter following me. And we got Ska Walter following me. Ska Walter, thank you so much. And we got Blue. Oh, Blue. You're so blue today, but I hope I can make you less blue. I want to say thank you for following Blue, and Skull Wolster. Thank you guys so much for the follow. Happy Wednesday. I hope you're having a beautiful day. Folks, we're back. We are working on day 20 of the advent of code right there. What are we doing? We weren't able to do yesterday. I was busy. Had some prior engagements that I had to take care of. The place is like an hour away. I had to be there early in the morning. I don't even want to talk about it. It was rough. It was rough. Nothing wrong with puzzle design in the XKCD. It's true. G, thank you for checking out that puzzle. All right, folks, we're doing day 20 of Advent of Code. If you're not familiar with Advent of Code, it's a series, and I'm sure you are. If you're here, if you've been here at all this month, but maybe you're new. Advent of Code is it's a small Advent. It's not a small Advent code. It's an Advent calendar with puzzles that come out every day. Thanks to the wonderful, the fabulous, the incredible Eric Wastel. And today we're doing day 20 because today is December 20th. December 20th. I did do 19th yesterday, intermittently on a laptop with it was rough coding on a laptop, folks. But I did manage to do it. Fun. I liked yesterday's puzzle. The first part was fun. The second part, the range splitting, I don't know how I feel about range splitting. It's a thing. I feel like it's a thing. It's a thing that had to be done. All right, here, we're going to do day 20 here, folks. Come on. Ben Jaxt 3829. Thank you for the follow, Ben Jaxt 3829. Ben Jaxt 3829. Ben. Oh, Ben. Thank you for following me. Today we got Ben following me. Thank you so much for the follow. Ben, thank you so much for the follow. Hope you're having a beautiful Wednesday. Phil says day 19 part 2 was just day 5 part 2 again, right? What did I do for... I don't think so. Was day 5 part 2 a range problem? Part 2. This is a map we can look at. What did I do for day 5? Look, they all blend together, Phil. Let's take a look. Let's go look at part 5. CD05. What did I do for part 5? I don't feel like it was the same, was it? What did I do for part 5? Why my mouse dexterity is so bad? Part 2. Yeah, it was. It's all blurs together. Day 5 was a number range problem. It was just a different one. I don't remember this one being so bad. Contains less than greater than. Yep, absolutely. You're correct. It was just a splitting problem. The one, day 20 yesterday was just like, or day 19 felt like maybe it was like disguised. Oh, I did it on another computer. Hang on, let's get a pull in here. So here's my implementation of day 19. It was like a bigger splitting problem, right? Forgot to use house use C# with Unity. I know. Sigian, this is why I write all my code separate from Unity, so I can use C# 12, and then I compile it to a DLL and drop it into Unity, and I just make calls to that. So my implementation for day 19, it was, yeah, Phil, you're correct. The type of problem was just another splitting problem. This one felt, day 19 was certainly harder in that there was so much parsing garbage. The parsing on day 19 was beefier, I think. But yeah, the parsing was a little bit awkward. The splitting was, I thought, harder on day 19. I almost threw my machine across the room on day 5. Interesting. I felt like I had a bunch of, maybe I was just less, you know what it might have been, Phil? Is a more recursive tree walk. Yeah, I did essentially a breadth first. I implemented a breadth first search, breadth first traversal of the splits, right? So I had a queue. So I start with a thing called a part range, and we do a split. Spura, I know, it's a lot of code. Every time I see your solution, Spura, it makes me want to go back into functional land because, the code in functional land is so tasty when you get it right. when you get it right, you can just keep straight. It just keeps slowing down until you just got like 7 characters. This is why maybe I should start doing APL again. I don't think anyone would want to watch me program in APL. People keep saying they want to watch me program in Haskell, but I don't believe them. I don't actually believe many people want to watch me program in Haskell. I think people would look at it and then their eyes would gloss over and they'd be like, this is not a fun thing to observe. Maybe though, maybe. But yeah, it's a lot of code. I was trying, I got stuck. So Phil, I think what was happening, maybe it wasn't so hard. I just wasn't able to sit down and work on it all at once. I was like working on it 15 to 20 minutes at a time and then having to get up and do stuff every 15 to 20 minutes. And so I was like distracted like crazy on this one. I could definitely rewrite it better. I don't know. I didn't think it was terrible. I just kept writing bugs. So maybe it was just me. I kept writing bugs. I discovered in records using this with syntax, it doesn't call the constructor. It actually does a true lens, and so my counts were off because I was doing this. And so when you make a with that changes one of these values, I assumed it was reconstructing this thing, but it doesn't, and so my counts were all wrong. So you actually, I had to do this thing anyway. I'm not going to talk too much about day 19 unless people really want me to. But I had fun with it. I thought part 1 was much more fun than part 2. But that's okay. We're going to do day 20, folks. Yeah, I spent 60 lines total counting empty lines and such. Gotcha. Most of my solutions in C# are pretty thick, Spura. C# is not known for being a terse, I would say terse programming language. I would say that it tends to take up more lines than most, like it falls into the category of, I think it takes up more lines of code than Java, because of curly braces and stuff. But let's take a look at day 20, post propagation. With your help, the elves managed. Leo Diego, thank you so much for follow. Have you met Leo Diego? One they have followed me today. You know Leo Diego. Thank you so much for following me. Leo Diego, happy Wednesday. Welcome to the stream, my friend. Hope you're having a beautiful day wherever you happen to be in the world. We are looking at day 20 of Advent of Code here. Pulse propagation. We haven't even started. We're just reading. We haven't even read it. I read, with your help, the elves managed to find the right parts and fix all of the machines. Now they just need to send the command to boot up the machines and get the sand flowing again. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather to communication modules attached to the machines that perform various initialization tasks, also act as communication relays. Where are you getting those challenges? They're from the Advent of Code website. You can check it out here. We're on day 20. Stubert. What a cool name. Stubert. Are you related to Dogbert? Related to the Dilbert? All right. Modules communicate with using pulses. Each pulse is either a high pulse or a low pulse. When a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. Well, it's nice to meet you, Sebastian. I hope you're having a beautiful day. Sebastian, have you been here before? It's not showing up as a first-time chatter. Did you have a different username? I don't recognize it, and I'm sorry about that. Let's get you here, and would you prefer me to call you Sebastian or Stubert? Sebastian. I could also call you Stu, Bert. I could call you Stu. I could call you Bert. I could call you Sebastian. Whatever you like. My code for day 19 was still large because I had a loop checking in there just in case part 2 is a recursive function instead of a walk. Gotcha, G. Yeah, I could have done, if you did a recursive function, I think you could do a depth first. You could also build it. I thought about a couple ways. You can build it from the bottom up, go just to the accepted, start with just the accepted results and build your way from the back upward would be another option. I did mine top bottom. I think you could start from the bottom and go backwards as well. All right, modules communicate using pulses. There are several different types of modules. Flip-flop modules are prefixed with a %, are either on or off. They are initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. Okay, receives a high pulse. However, if a flip-flop module receives a low pulse, it flips between on and off. Okay, so low pulses will turn our flip-flop on and off. High pulses are ignored. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Sebastian says, I've been on your stream once before and I started to follow you immediately. Well, I'm glad you're here, my friend. Last time you were teaching some basics of C#. Gotcha. Yeah, in December we're doing Advent of Code. Advent of Code, it's how I got my start streaming. I had a lot of fun doing it, and so we're back at it. Yes, ChatGPT just solved one AOC. I hope it can't and I don't have to become a delivery man next year. I think it's pretty good at solving them, Sijian, unfortunately. Hey, what's up? Did you do 19 off stream? Topologist, I did 19 off stream, so I couldn't stream yesterday. I had a bunch of chores I had to do related to finishing up at the other house. So we moved, and we're trying to get out of it. We're trying to get rid of the other house. We're calling it the bad house. Pretty sure it's built on top of some sort of cursed landmark site. It was terrible. We got out. We're pretty sure it was built on top of a cursed location. But we had 2 more days and we should be done. We had to go yesterday to finish up the cleaning, and that was cursed. We didn't finish, so I have to go back again today. Hopefully we get it done and we have an inspection tomorrow, and then we should be free. We should be free at last. Let's look. So we have flip-flop modules. But yeah, I didn't do day 19 on stream. I did it off stream. It was like super distracted too, like 20 minutes at a time over the course of the whole day. Conjunction modules start with an and. But Sebastian, I'm so glad you're back, my friend. If you have any questions, don't hesitate to ask. We do a lot of C# here. In January, we'll get back to doing some more basic C# stuff. All right, conjunction modules prefixed with an and. Remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse, so they have they like forward it for each input. When a pulse is received, the conjunction module first updates its memory for the input. Then, if it remembers high pulses for all inputs, sends a low pulse. Otherwise, it sends a high pulse. Okay, so conjunction modules send out pulses. Flip-flop modules also send a low pulse, but conjunction, if it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Okay. These send it. They have different conditions under which they send low and high pulses. There is a single broadcast module named Broadcaster. Aptly named, folks, aptly named. When it receives a pulse, it sends the same pulse to all of its destination modules. Here at Desert Machine Headquarters, there is a module with a single button on it aptly called the button module. When you push the button, a single pulse, low pulse, is sent directly to the broadcaster module. There's a single broadcaster module. When it receives a pulse, it sends the same pulse to all of its destination. Okay. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing a pulse. Don't do it. Don't cross the streams, folks. Don't cross the stream. Something to do. Stop. I'm back. Sorry. You gotta be careful not to cross the streams. Stubert says, I'm also using C# mainly, but now I'm trying to focus more on Python. Gotcha. I like to watch how you approach these challenges and trying to learn something also. Fantastic. Soft PDDR. Soft. Oh, soft. I like to feel it, you know. 'Cause soft things, they feel so nice. It's like cashmere. It's like cotton. Soft PTDR. Thank you for following me today. I hope you know how grateful I am to you. You're so soft. Welcome to the crew. Soft. Happy Wednesday. Welcome to the crew. Happy to have you here. All right. Pulses are always processed in the order they are sent. So if a pulse is sent to module A, B, and C, and then module A processes its pulse and sends more pulses, the pulses sent to module B and C would have to be handled first. Okay. So we have like a queue of these pulses that are coming through. The module configuration lists each module. The name of the module is preceded by a symbol identifying its type. And then the name is then followed by an arrow and a list of destination modules, for example. Okay, so we're gonna have our broadcaster. And it is connected to A, B, and C. So we know we're gonna have, so this is like a directed graph. These arrows make me think it's gonna be a directed graph. And just the description here. So when you push the button, broadcaster is gonna send low to everything. It always sends low, is that true? Yeah, send. So it's gonna send a low to A. That A is gonna fully process, then we send a low to B. B fully processed, then we send a low to C. C fully processes. A is a, what do they call these? A flip-flop module. It flips on. If it was off, it turns on. So A will be off, it'll turn on, and then it will send a high pulse to B. If it was on, it turns off and it's a low pulse. So, okay. So there's probably an example here we'll follow through. In the module configuration, the broadcaster has 3 destination modules named A, B, and C. Each of these modules is a flip-flop module as indicated by the % prefix. That bean water is delicious, folks. A outputs to B, which outputs to C. A outputs to B. B goes to C. And C goes to inv, which is a conjunction node, so it's a little bit different. A conjunction module, I'm thinking in graph terms. It's a module, so these are modules, not nodes. The modules are kind of nodes. We'll probably have something else maybe in our graph here. It acts like an inverter. Hang on. A outputs to B, which outputs to C, which outputs to another module. And inv is a conjunction module and indicated by the and prefix, which, because it only has one input, acts like an inverter. It sends the opposite pulse it receives. It outputs to A. The conjunction junction. What's your function? Thank you, Mary. Thank you for that. We know. Look, what was that? Schoolhouse Rock. Schoolhouse Rock conjunction. Is that what it is? Old time 70s grammar. Conjunction junction. Thank you, Mary, for the reminder. The more you know, we need a more you know button. The more you know. We need a more you know button. If anyone got the more you know video for me to add, feel free to DM it to me. I'd love to add it when I have more time, folks. There's no time. Time is my greatest enemy these days. By pushing the button once, sends a pulse sent this way. So button has a low to broadcaster. Then this gets queued up. A goes to B, goes to C. So we do A. We hit A, which is going to turn it from a low to high. We hit B, it goes low, high. Hit C, it goes from low to high. A sends a thing to B. Hang on. Wouldn't that make B go low? Because B got hit. Okay, so a B goes to C is going to happen here because this hit first. These is a queue order. So this, we queue up these. We queue up these. Running this one queues up this one. Running this one queues up this one. Running this one queues up this one. Running this one. What I don't understand here. Running this one. Shouldn't that queue up? Mary Cat, getting the family ready for school. Nice. Thanks for helping the family get ready for school. I'm on break. I hope they get a break soon. I'm very lucky. I feel like my school gets we get 3 weeks off. Most people I talk to only get 2 weeks off of school. And so I feel very fortunate. I feel very special. I'm a little ABC. Oh, A goes to B, B goes to C. I'm confused why this one is in between here. Because on the flip-flop, It flips between, if it was off, it turns on. If it was on, it turns off and sends a low pulse. After this sequence, the flip-flop module all end up off. So pushing the button again repeats the same sequence. Here are more interesting examples. I'm slightly confused on this. You press the button. Broadcaster sends low to these guys. When we hit A, it shouldn't cue this. That seems correct. What doesn't make sense to me is when an A going to B, A sends a high to B. I don't understand how the in-queuing here is working. Let me read it one more time. Are on or off. They are initially off if a flip-flop module receives a high pulse. They are off. If it receives a high pulse, it is okay. Oh, if it receives a high pulse, it is ignored. Okay, here we go. I remember saying that I felt that, and then I read this, but it skipped out. If it was if it receives a low, it sends them out. Okay. So it sends all these in, which causes these to happen. But when A sends a high to B, nothing happens. When B sends a high to C, nothing happens. When C sends a high to INV, that enqueues INV, which will send a low. So in a conjunction, the type most recent pulse here, they initially default to remembering low. When a pulse is received, the conjunction model first updates its memory to that input. Then if it remembers high pulses for all inputs, it sends a low pulse. However, otherwise it sends a high. So then if it remembers all high inputs, so because C sent a high impulse, all of its impulses were high, so it sends a low to A, low sends a low to B, which causes B to send a low to C, which causes C to send a low to INV. Because INV did not receive all high inputs, it sends out a high to A. And then because A received a high, it does nothing. When it receives a high, it just highs absorb it. Okay. All right. After this sequence, the flip-flop module all ends up off. Here's a more complex or more interesting one here. Hex tree. Oh me, oh my, we got a hex tree. Not an octal tree. Not a binary tree. You know it's hex tree. Oh, hex tree. Thank you for rating me. Let's give a shout out to the one you know who programs in Python on the go. We got Hextree rating us on this day. Hextree, how you doing, buddy, folks? I see that heart on your... I implore you. I implore you, chat. Look right here. You see this? Oh, hang on. Don't break the heart. Don't break the heart. Give that heart some love. You see this heart here, folks? That's for our good old buddy here, Hextree. We gotta love Hextree. You see that heart there? If it's not green, click it. Hey, did you click it? Click that heart. Hextree, today's problem was an ordeal. Oh boy. We're just reading through it here. I'm trying to understand the problem. We haven't made it through the understanding, but thank you so much for the raid, Hextree. I hope you're having a beautiful day. Were you able, let me ask, were you able to make it through? Were you able to make it through? Okay, so I think I understand. I mean, I don't know if I need to read all of these all of these things here. The important bits, good, you solved it, good. That gives me hope that I'll be able to solve it. Reading through, there's some rules that this thing has to follow. We have to build up the graph, and then we have a bunch of samples we can do here. GPT 10,000, 10K, nice to see you, my friend. Happy to have you here. Yeah, so I think these are just more example inputs for me to understand when I push the button, what is the outcome there. But let's see what it's asking. This, to get the cables warmed up, the elves have pushed the button at 1,000 times. Okay, so we're gonna have to do a simulation here. Push it 1,000 times to get as results, including the pulses. How big is our input? Not that bad. This is a small graph. Ask GPT to solve it. Give GPT this input. Ask if GPT can solve it. Hextree, I'm glad you solved it. We're gonna see if we can implement something here. We're gonna see if we answers 42. Yeah. The same thing happens every time the button is pushed. 8 low pulses, 4 high pulses. So after the pushing the button 1,000 times, 8,000 low pulses, 4,000. Multiplying these gives you 32,000. Okay. So in the first, what are we at? Consult your module configuration. Determine the number of low pulses and high pulses that would be sent after pushing the button 1,000 times. Waiting for all pulses to be fully handled after each push of the button. What do you get if you multiply the total of low pulses sent by the total? So low pulses by any module, I'm assuming. To get cables warmed up, push it. And first example, this thing happens every time 8 low pulses and 4 pulses are sent. Okay, we have to track. Okay, all right. We get a couple sample inputs. All right, so we get 2 sample inputs. Boom. Let's write some stuff here. Public static read-only string sample input 1. Pop that in there. I saw that explosion going on. Who we got? Calvo Meek. Calvo Meek, thank you for following me. Welcome to the family. You know I love when I get a follow. And today we got Calvo Meek following. Thank you so much, my friend. Calvo Meek, I hope you're having a beautiful day. Welcome to the stream. Welcome to the Academy. Hope you're having a beautiful day. Hope you're having a beautiful Wednesday. All right, so this is sample input 1. Let's get sample input 2. Boom. Public static read-only string sample input 2. Place trim. Okay, and then we're gonna write. I don't think I can do a theory with these. We're gonna try the theory. Inline data. Sample input 1, and the expected output is this number. What is that? 32 million. Okay, let's see. Well, let me do this. Test sample input part 1, string input long expected. Yeah, it doesn't let me do that, sadly. So I just got to do both. Make it a fact. It can't accept it because it is not a constant. Even though it's read-only. Can we make strings consts in C#? I don't think we can. I think they're objects. Okay, so we'll do day 20 dot part 1 sample input 1 dot should be. Oh, I don't know if I imported shouldly. Strings can be const, can they? Public const. No, we can't make strings constants. Must be constant. Oh, we can do that. We can do that. I cannot make it a const. I can't do these things to it. Interesting. Interesting. Yes, yes, indeed. I see that now. Do I dare change the way I've been doing things this whole time? Inline data. Yeah. So this means at compile time, this is part of. There's no processing that needs to be done to set it. All right. Sample input 1, 32 million. Do I have to do const string? Input in long expected. No, stop expected. Part 1 input dot should be expected. Don't tell me what I have or don't have, Nick. How dare you? How dare you? All right. So in my tests.net add package should lead with an L, 2 L's, version 4.2.1. How dare you wink at me twice without a smiley attached to it? All right, let's reload this. Look, I was pretty sure you could make strings const. They have to actually be constants is the problem. All right. And now I'm just inconsistent. All right, 2. This one should be this big ol' number. Boom. And then we'll import the shouldly. Okay. Okay, Hextree, thank you so much for submitting your solution to us. We'll take a look at that someday. Someday, maybe, possibly, if there's time here. Folks, unfortunately, I can't stay that long. I have 3 hours today. I have 3 hours again today because of, yeah, I have 3 hours today. What am I trying to say? I have 3 hours today because I have to drive an hour to go back and finish the mess. Yes, are you asking what these 3 quotes together do? This allows us to do a string literal. It says this is the whole string, so we can put like new lines in there, and it ignores the padding on the left side here. So it ends up being just this string here. I don't know if that made sense. It's, what are these called? There's a word for it. Dragon Spirit Games, welcome back to the stream. How the heck have you been? And Kuani, I missed you. Kuani, let's see, what did Kuani say? Oh, strings, Kuani, I didn't miss you. I just didn't say hello. I'm doing absolutely wonderful. Dragon Spirit Games. I hope you're doing well. Also, you can use as many quotes as you want. You can use as many quotes you want. Say inside my string, I'm gonna mess up my input here. Say I wanted to put double quotes around it. Say I wanted to put triple quotes around inside of there. If I do 5 on this outside, it allows me to do as many as I want on the inside, up to that many. So you can it basically allows you to specify your delimiter. I hope I didn't mess up my input there. Let's rename this here. This is going to be day 20 tests. Little down for not getting a grant I applied for. I'm sorry to hear that. That's always a bummer. Were you applying for a grant for your game, Dragon Spirit Games? All right, so this will definitely fail on us. I'm sorry to hear you didn't get that. I can't tell you how many times I've not received a grant for research. You got to apply for so many grants to get them. The competition is spicy. Competition for grants is spicy, my friend. So you got to apply. If you're doing research, if you're doing stuff where you're trying to get grants, apply for as many as you possibly can, because the competition is fierce. Competition is fierce for that money. Okay, we need a parson. We have modules. We have a module here, so I'm gonna write. We have 2 types of modules. We have broadcaster special. So we kind of have 3 types of modules. We have flip-flops, we have conjunctions, and we have a broadcaster. And they have it's like no module. All right, so I'm going to define I kind of want to do an interface here for my module because they act differently. They act differently for each one of these. I could also have I could also just do a module and have the type as a here. So I could do char or module. So public enum module type. I could do this. I could do this. Or part of me says, well, maybe I should have an interface with, because essentially we want to do public, something like public receive. We have when we receive a pulse void, egress and ingress, receive pulse, and then it's sort of like bool is high. So we have like a high pulse or a low pulse, and then it does a thing. It does a thing when we receive a pulse. It needs to send out. Honestly, we might need a type called pulse. Public record pulse. Bool is high. And then the destination is like, I could have it be a module or a string destination. So we could say that receive pulse returns an IEnumerable of pulses. All right, so when receive a pulse, and I'm going to call this handle pulse. Pulse incoming. We need to do something. Throw new exception not implemented. Making accessible games isn't easy and unfortunately not free either. Yeah, nothing. Look, Dragon Spirit, nothing's free. Nothing's free in life. Oh, I didn't think you'd give up at all, Dragon Spirits. You got that tenacity. You got that tenacity, folks. Do you guys know Dragon Spirit games? Dragon Spirit, I haven't seen you stream in a while. You still streaming? Be sure to, I know you stream sometimes. Be sure to give Dragon Spirit games a follow, folks. Making a game called Gaia. It's, your daughter, I believe your daughter's the main protagonist in the game. How is the game coming along? Goob, welcome back to the stream. We're just giving a shout out here to our good friend Dragon Spirit Games. Some people call him the Bob Ross of pixel art programming. Paddywhack says, we all got the tenacity to advent a solution to this problem. We're doing our best. Thank you for the whoa. Every Monday, 8 p.m. Amsterdam time, just not next Monday as it will be Christmas. Gotcha. So every Monday, 8 p.m. Amsterdam time. That's probably why I haven't been there. Mondays, I've probably been teaching at that time. I think that's around noon my time. And I've had a class on that during that time. Goob, I'm so glad you're here, my friend. How you goobin'? My friend? You goobin' well? How's things goobing for you? All right, so we're going to handle this pulse. Well, we're going to have to. But part of me was thinking, well, we have a couple different types of pulses. And all right, so our module is going to have a list of, it's like labels to other modules. We want to be able to look it up. So it's not the actual modules themselves. We have targets in them. So I don't want to, a pulse, I think this is a string that's a destination. It's like a label to the next things. If I do it as a module itself, I think we might run into some problems. Treyanko, now I want to see if you have more luck with the OO approach. I started out the same, and then in Freshen replaced a virtual function with a member function pointer. Ugly, but the lesser evil. Yeah, so I always get scared of doing. So there's just like doing not necessarily inheritance, but you can easily run into some pain when you're doing these puzzles. I did it yesterday with OO and was like kind of really dissatisfied with how I did it. I ended up doing object-oriented yesterday. I had an interface called condition, and then I had the else condition and an if condition that did my splits for me. And the code got so gnarly. So I'm not sure I like it. Goopin' well for sure, Goob says. But Treyanko, welcome back to the stream. I hope you have a beautiful day. Yeah, Paddywhack, knickknacks. Nice to see you on this beautiful day. Yeah, so I'm not sure I think the easiest thing to do here is to make this a string destination. Because I'm going to, in my module, I'm going to need to have a list of destinations here. And so my module won't be easy to look up, I think, in a map. Or to make it, it won't be easy to do an equality comparison. My module can't be a key. I'm going to be doing it on the destination here. So here, I think you can't create them until you know their type. Yeah, so that's what I'm saying. Like, as I'm parsing, I don't want to have, as I'm parsing through this thing, it's like I'm just gonna have labels here for where we're going, because having them linked together by the actual module, I can't do it yet unless I defer initialization somehow, and then it's just painful. So I think I'm not going to do that. Francisco S1, Francisco. Hope you guys know it's true. We've got Francisco following, and I'm singing so poorly today. We got Francisco, and I'd like to say thank you for following me today. Oh, Francisco, welcome to the crew. Francisco, thank you so much for the follow, my friend. Happy Wednesday. Hope you're having a beautiful day. Yeah, so I think what I want to do is have a type. There's a couple different types here. There's the broadcaster. There is a flip-flop. Let's go with module type use short here. Flip-flop. It's going to be %. And then conjunction is and I'm gonna go with broadcaster is B. Broadcaster's B. That's the first thing here that we'll read as a B. That's how we'll identify it as a broadcaster. So we'll see here if we're gonna go. All right. So now our module type. A module has a module type. You've been singing in your stream. That's hilarious. I'm glad to hear your string and singing. I don't want to use the word type because there's a type class that TYPE. There's a class in C# called type that gets confusing, so I'm just calling it M type here. And then our module has a list. The order is important here, so it's going to be a list of destinations like this. Why they want me to look it's to laugh with you. It's to laugh with you. I don't know why people like to listen to me sing either, Dragon Spirit Games, but it seems to work. It seems to get people in the door. And people, look, I just want people to smile. I spelled incoming wrong. All right, so we have a type and destinations, and then what we could do, handle pulse is really going to be based off of our type here. Okay, it's going to be based off our type, and we'll do. So I kind of want to. There's some stuff we need to do here. So each type does something slightly differently, because if M type is broadcaster, if it's a broadcaster, we could do a switch on it too. This might be so what I really want to do is I want to do a switch here. I want to have this pulse, a function of pulse and I enumerable pulse. handler. And I want to do this. I want to do the following, where I do a M-type switch. This is essentially if I did subclassing, this is what this would do. Somehow, I guess it may have not been smart to make 25,000 channel point, 2,500 channel point redeem. Some already have over 10,000. I have people here with like, I think Moon has like 200,000 channel points of Captain Coder points. Captain Coder points. They're not really channel points. And so we're gonna do M-type if we got broadcaster.
Whoa.
Thank you for the whoa, Patty Wax. Pulse goes to this Y. This should be, sorry, a module type dot broadcaster. Okay, so if we're a broadcaster, we send a low to everyone. So we're gonna do destinations dot select. Destination is going to go to new pulse false. I'm going to create, I know this seems dumb, but I'm going to create an enum called high low or pulse type. This boolean's, I'm going to lose my mind looking at this boolean here, I think. Enum high low. Look, I think I'm doing too much here. Pulse, comma, destination. All right. So our broadcaster is going to give us, is just going to do this thing here. Turn handler of incoming. Like this. Okay. You ever make a match 3 game before, Cap? What is match 3? Is that I'm not sure what a match 3 game is. What's a match 3 game? I've made a game called Beard Jeweled match 3 game. Match 3 and Bubble. I don't want to click on match 3. Candy Crush, for example. Yeah, I made a game called Beard Jeweled. Which, Jay Collard, do I have Beard Jeweled here? 1 second, let's go find this thing. Search Beard Jeweled. I made a game. I wanted to do something on Android. Do I have any screenshots of this? That's too bad. I made a game in Android that is kind of like Bejeweled. It's kind of like Bejeweled, but all of the gems have beards. Where are my beards? All right. So we have these. All of my gems have beards. So there's a bunch of different gems with beards. It's called Beard Jeweled. It works differently than Bejeweled, though. It works differently than Bejeweled. You can match them together, but the way you score points is you have to get combinations. You can swap the positions, and you get bonus moves. You have a limited number of moves, and the goal of the game isn't so you'd have a grid, right? So you have a grid of gems. And your goal isn't just to clear out gems. It's part of the goal. You will have a task that you want to complete. So you'll have a series of shapes that it wants you to clear out. And the only way to do it, if you get a match 3, it clears. If you get three gems of the same type together, it clears. But you have this queue of challenges you need to solve. So a challenge might be, can you clear this shape? It's not, so you need to clear, you have to make a move such that these 7 pieces get cleared all at the same time. So it's all about maneuvering the board in a way such that when you cleared out, the combos that you put together end up clearing out this chunk. It's not just clearing 7 at once. You have to clear the 7 in this particular shape all at once. And so it's all about maneuvering your pieces. And so you can freely swap 2 pieces. You can freely swap, you get like 20 moves or something. You can swap 2 pieces. It's not available on Android. Look how old this is, from 10 years ago. I think it was for like Android 6 or something. But yeah, it's a little bit different. Popcorn, welcome back to the stream. Nice to see you. So it's a really, I thought it was fun. But the idea is you're not just trying to clear out a single 3 or a row. You have to reposition the board in such a way that when the piece is finally clear, there's a combination that happens that'll get you this particular shape. So this was done in pure Java 10 years ago, which is wild. I know I have some videos of it somewhere. If you on the Discord, if you go on Discord and tell me, I will find it and send it on Discord. I just don't have time to find it right now. I am Frey. Welcome to the Captain Stream. I want to say welcome to the crew. Everybody give a shout out here to I am Frey. I am Frey. Thank you so much for the follow. Happy Wednesday, my friend. Happy to have you here on this beautiful day. Welcome to the crew. I've not yet made it. Yeah, so I would not personally recommend doing an Android game using Java directly, but that's just my experience. I did not have a lot of fun. That's not true. I had a lot of fun doing it. But there are tools for doing it. I wrote it in pure Java. Okay. So for a broadcaster, we literally just send out a low pulse to everything. Nick suggested, Nick, can we do this? Using true is equal to, high is equal to true. Can we do that? Boolean dot true. I don't think we can do that. I can't do this, right? Yeah, I want to type alias for high and low. I could do something, just an empty project, writing it all without any libraries. Yeah, that's exactly what I did for Java. I would not recommend doing anything in pure Java, but that's just me. Look, Java is industrial strength. Java is a great programming language. It's just not the most fun. I find Java not to be the most fun programming language to use. But Java is a fantastic programming language in general for like enterprise software. It's a great choice. All right, so module type dot flip flop. We have a pulse coming in, and the flip flop here is going to do something. I think Kuwani, I think you can make any language look terrible, though. There are some languages that just look a little bit more beautiful than others. Looking at someone else looking to learn how to make one, just realized one of my favorite mobile games got pulled from the App Store. It's basically unplayable now without the now inaccessible microtransactions. Yuck. Yeah, I think Match 3 is a fun one. Tetris is another one I think is fun to implement. Have this return that for now. Module type dot conjunction. And we'll have it just return this for now. Okay, so we have our different ones here. And then we can have this throw new exception, invalid module type, M type. Okay, so this is essentially, if I did subclassing, this is essentially what happens when this calls. It dynamically selects one of these and calls it based on its type. I just did it this way for some reason. But this is essentially, if you were going to do it, it's not quite the same. It's not quite the same, but it's very similar. But if we're a flip-flop, what do we do here? Invisible Contestant, this challenge looks scary, but turned out to be quite fun. Nice. It's looking pretty good to me. All right, so let's look at what is a flip-flop supposed to do. They're initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. Okay, so we're gonna do a thing for our flip-flop that just says if pulse dot is high. Can we do a yield break? Cannot be used in an anonymous lambda. Oh, okay. So instead we got to do a return. So this will return an empty enumerable. It does nothing. Otherwise, if it's low, however, if a flip-flop module receives a low pulse, it flips between on and off. Yeah, so there's state here. Public bool. What are they calling this? It flips between on and off. Bool is on. And we're going to start, we'll have this be false to start with. And so if it was off, however, it receives a low pulse, it flips between on. If it was off, it turns on and sends a high pulse. So we'll say is on is equal to the opposite of is on. So it flips. This should really be a class, not a record. Records are not supposed to be mutable. So I'm doing something kind of bad practice here of having some mutability in here. And I could also make this get private set. So no one can touch this outside of this. All right. So we flip, and then all of our destinations, if it was on, it turns on and sends a low pulse. If it was off, it turns on and sends a high pulse. If it was on, it turns off, sends low pulse. So it swaps and then sends out its current state. It swaps and sends out its current states. So this would be destinations.select, destination, and then we're gonna forward a new pulse of is on destination. Okay, so it's gonna create a new pulse for each of its destinations here that has its current state. So let me double check, sorry. If it receives a low pulse, it flips on and off. If it was off, it turns on and sends a high pulse. So it flips and then sends the type of pulse it is. Darth Blackman, welcome back to the stream. How you doing, my friend? So nice to see ya. Greetings, I return. Welcome back. Greetings, my friend. It's nice to have you. All right, so now we got to do our conjunction. We also need to count pulses. We can count that outside. We can count that in our queue. We can pull them out. Conjunction modules. Remember the type. Either that, or I can keep track of these modules of like high pulses sent, low pulses sent. So I could also do a public long high pulses sent equals 0. Public long low pulses sent equals 0. And every time we send a high low pulse, we can do a count on that. I can do it like that. I think I'm gonna have a global count. Let's keep track of it. This name, you folks making these great long names to try and get me to sing them, or maybe Nizek Anes Kabunasaria. Neza ke uneses ke buonasera. Neza ke unses buonasera. Yeah. Thank you for following and welcome to the stream. Thank you for following. What an incredibly long name. Thank you for the follow. Let me know how I should pronounce that. Let me know if you got a nickname for us. But happy Wednesday. Welcome to the stream. Welcome to the crew. Happy to have you here with us on this beautiful day. Okay, so our conjunction. Remembers the type of the most recent pulse received from each of their connected input modules. Okay, so it has a dictionary. So it needs to know ahead of time who's connected to it. Jingle bells, his name smells, his BAME smells. Let's go all the way. Buona sera is good evening. Rest doesn't ring any bells. Spoof. Why is anybody could use bit sets? It's true. It's true. Why? Why would anyone ever want to use a dictionary? Ever. So this is making me think I want to go down into a subclass because conjunction has like some additional state associated with it that flip-flop does not. Yeah, so it has additional state that flip-flop does not. It makes me want to. So these all have destinations, but the conjunctions, we need to track the inputs in there. So if you want to remember in the conjunction, yeah. So there's some extra stuff here that I'm missing. So pulse needs a string source. So our module is going to need a string name like this. And so we need to add in a source, which is going to be our name. Name like that. We need to conjunction here. I guess we can say that all these, we could do, this is rough because I need to know my inputs first. So when I parse this thing in, I need to build up the whole graph once, I think, ahead of time before. We need to be able to modify this. The other thing would be to have like an edge set passed in, or some kind of static graph. I could do that. I could have some kind of static dictionary from string to list of string in edges. So this would say, given a label, what are the edges that come into it? So like I'm looking at this, I'm like, I kind of need a whole graph during parsing here. Public static dictionary string list string here. These are like out edges. So I kind of need, this would be our destination edges. And this here is sort of like our incoming edges. So given a name, give me all of the edges that go into that. So these are all the receivers. These are all the nodes that send me something. And these are all the nodes that I send stuff to. If I do this, I can get rid of this destinations here. And instead of destinations, I would say, I'm going to call this out edges. Apparently, I think incoming, my brain wants to do two M's, and we do out edges of name, like this. So this becomes out edges of name. Okay. And this thing gets constructed when we parse. So this is like a global constant. I don't know how I feel about this. This feels hackery. Komar! Yo, Komar! Welcome to the stream, my friend. Hope you're having a beautiful day. If we do this, we could actually... No, not yet. I'm going to do this. Love me some global mutable state spoof. It's terrible. Show up that resets between different tests. It doesn't. It does not. Yeah. So it's like we almost need this information to be coming into these methods. This is just me working through the problem, how I want to construct this thing. I kind of need to have a whole public record. What did they call this whole thing here? Komar, what have you been up to, my friend? We need a whole graph, I think, here. Yeah, global state is terrible. What did they call this whole things? The machine pulse propagation machine, fix all the machines, command to boot up the machines and start things flowing. Maybe I'll just call it module network. Module network. And it essentially has this. Yeah, our module network has these two things. They're not static. And we can add an edge to it, you know, and we'll do a, this is getting hard. This is getting rough for me to conceptualize here. Like, this is not gonna work. This in last year's AOC, thanks to you. I'm glad to hear it, Komar. How has your experience been? How has your experience been here, friend? What we could do, we need to keep track of our incoming edges, our outgoing edges. We can make these private. I'm gonna make this a class. And we're gonna have a parser for it. My modules should do we have nested classes here? If I put you inside, I don't have access to that. An object reference required. Module network. How do I want to have like a module network. My modules are associated with that network. How do we make a nested? Can we just not do it with a nested? Can we do this? Or nested classes are really considered a bad idea? C# nested class. Access parent. Or did I make them public? There's actually no implicit reference to the instance in the closing class, so you need to pass such a reference. And typical way of doing this is through the nested class constructor. Okay. All right, well, in that case, network. That's what we'll do. All right. In Java, this is me, just like my Java coming in. In Java, if you nest a class, you need an instance of the module network to construct those modules. We'll need a reference to our module network. And so now this becomes network.outEdges. Network.outEdges like that. This whole thing's a nightmare. I'm not happy with where I'm at with this. Is this building.net build? My module network constructor is just so I can create one of these. It's not going to have a constructor. Private module network. There, no one can call it but me. Get out. Get out. This is preventing me from having global state, essentially. So there's going to be a parse that builds out all of my modules. And then I'm able to get out. Yeah, it's like I'm not super happy with what I have here. I'm not super happy with what I have here, but my conjunction here is able to look out the incoming edges to it is what I need here. So it needs to check. It needs to have a memory. Remembers the type of the most recent pulse received from each of their connected input modules. So this will have a dictionary from string to bool, and this is going to say this is going to be a. Let me make this private. Last input here, And the initial default, remember a low pulse for each input. Yeah. So by default, it's a low. So now we want to say, when a pulse is received, the conjunction module first updates its memory for that input. Then if it remembers high for all inputs, it sends a low pulse. Okay. So we need to go through, we need to get all of its incoming sets. So it's gonna be incoming network.incoming edges of name. So these are all the edges that we have here. And we want to say if all, we want to do a select. We need to pull these out of our last input of incoming, or incoming. Apparently I need, my brain wants to put two N's on it. Module name. So this would be our module name. And we need to do like get value or default of module name false. So it's false by default. And then we want to say all have to be true. Okay. So this is saying whether or not all are high. Okay. They initially default to memory low. When a pulse received, the conjunction first updates its memory for that input. So in this case, we'd say last input of pulse dot source is true. Oh, not true, is pulse dot, and my autocomplete's not working right now, is high. Okay. And then we get this, and we're gonna say if this, all right, so this says, I'm gonna just write a bool here. Bool, all high. Just to make it read maybe slightly better, who knows. And then if all high, if it remembers all high for all the it sends low, otherwise it sends high. If it remembers highs for all, so if they're all high, I'm going to return network dot outgoing out edges of name dot select destination new pulse. It's going to send out a low. If they're all high, it sends a low. Name to destination. Otherwise, we can cheat this, right? It's gonna be this, and it's gonna be not all high. There we go. Prophet, that's what I thought you had to do. Looks around. Sorry, I missed some. When a ball monster collapsed with a ball of elves and a ball of humans, I can hear the claws on the hard rod. Tyndall, I don't know if I said good morning to you, but I hope you're having a beautiful day, folks. You guys know the incredible, the wonderful, the powerful, the almighty Tyndall. We gotta get your Zelda cat, your cat intro on here. I'm so sorry I haven't had time to just had the word conjunction in there. Yeah, Tyndall, I hope you're having a beautiful day. Folks, you guys don't know Tyndall, incredible .NET developer, brilliant man. We love him. Love him so much. And Prophets, thank you so much for being here as well. Thank you so much for being here as well. All right. So I believe this is the logic for each one of these. It's the logic for each one of these. I'm not happy. I'm not happy. Can you tell I'm not happy? All right, let's parse out a module. So we're gonna need one more thing where we have like our public dictionary string to module nodes. These should all be private, if I'm being perfectly honest. They shouldn't be accessible outside of here, but we're gonna do a parse. A public static module network parse string input. And it's going to construct a module network equals new module network. And at the end of the day, it's going to return that network. But we need to go through every line in this input. So we're going to do input.replace line endings .trim .split. Okay. Can you put an extension method for a class inside of a class? I don't think you can. I think you need to have a separate public static. My question is, why would you want to write an extension method in there? I don't think you can. I think your extension methods can only be in a static class. Public static tests, a void test extension, this module network, dumb. You can, apparently. Apparently you can. Why would you do this? I have no idea, because this is... why is this not yelling at me that there's a this here? Oh, it's yelling at me right here. This extension defined a non-generic second. Thank you. I was expecting there to be an error there. Spoof, thank you so much. And then we're getting part 2. Yeah, I should probably, like, if I was doing smart things, I'd make this private, and then I'd have like a module, like get outgoing edge type thing. I'm not happy with this. All right, so this is our string rows. And then for each row, for each string row in rows, we are going to pull out something like this. So row dot splits on our forward arrow with spaces. Or I could do trim entries, remove empty entries. I could do it this way as well. I'm gonna do a space in there. I know there's a space on them. And then can we do a match? I don't think we can do a match the way I would want to, but we'll do string parts is this, string array parts. Our right side, so it's gonna build up we're gonna create a module here. And then in our first, on the left side, if parts of 0 is broadcaster, we can do another thing here. This is going to be a list of string destinations is equal to parts of 1 dot split, comma, string split options trim, string dot split options remove empties. Need an or. String array. Okay, these are our destinations. These are our out edges, so this could actually be a string array very easily. I could do a to list on it as well. All right, so if missing a semicolon, I'm assuming. All right, so our destinations. If it is a broadcaster, we're gonna create a nodes of broadcaster is equal to a new module of module type broadcaster, and network module this. Sorry, not this. This will be network. Okay. What is this complaining about? It's require. Oh, this is network dot nodes. Okay. So we're going to add that in there and then continue. Otherwise, we need to pull off that first character to determine the type. So we're going to do a module type. Type is equal to parts of 0 of 0. This is the first character here. And we can cast this to a module type like that. Then our name, string name, is going to be equal to parts of 0, and then we skip the first character and get the name. And then network dot nodes of name is going to be equal to a new module. Oh, I forgot one thing. I made a mistake here. I've made a mistake here. Since C# 9 or 10, I believe. I think C# 9 introduced it. I think it does a smart. I think it does a span. I don't know. I think it might. The answer is it probably depends on which version of .NET and C# you're using on how smart it is. Yeah, I think that's the real answer. You're going to do a new module of type name network. I didn't build up our outgoing and ingoing edges. Okay, so when we have our broadcaster, we also need to say the following. We're going to say out edges, network dot out edges of broadcaster. It's going to be equal to destinations. Okay. Like that. Our network dot out edges of name is equal to destinations. And now we need to go through each one of these destinations. This goes until the 25th, Tuber Tugger. So Advent is December 1st through 25th. That's what an Advent calendar is. It's the days leading up to and the day of Christmas. We're almost there. We got this and then 5 more. So we got 6 days here. Our in edges is a little bit different. So I'm going to write a little network dot add incoming edges, and this is going to take in name and destinations. All right, so public, make it private, void add incoming edges, string destination, and then this is a string array target, like sources. Okay, so it's like the inverse here. Give up after day 18. I'm gonna do them all, even if I don't get them all done on stream or on time. I will come back and do them. I managed to do them all last year, which was very satisfying. I can't tell you how satisfying it was, but I always encourage people not to give up. You don't have to do them all. It's just it's a personal challenge. It's a personal challenge. Do as much as you want. I think if you get stuck on one, don't stop. Don't stop. Just keep going. My kids definitely have an advent calendar with the days to New Year's. I know it's not official advent, but some people include it. Gotcha. I honestly don't know enough about it to know. I know I was raised Catholic, and we made advent calendars. Like, we would make them on December 1st. We'd make our own advent calendar and like give it to someone, or you make it for ourselves to count the days down. It builds some excitement, I suppose. Okay, so when we add an incoming edges, for each string source in sources, we need to go through our sources, and these should be lowercase to be proper. Yes, you are correct. I did make popcorn garlands as a kid. Triangle, that's such a good one. I probably wouldn't do that in C. C sharp is just so kind of verbose. If I was in Haskell or something like Clojure or Rust, I think under 100 lines might be reasonable thought. I could always so here's the thing, I could always cheat and, like, you know, remove white space and stuff. 104 lines, Phil. I try not to think about the number of lines I write. I over-engineer everything. So the simple thing to do here would be dictionary. Not dictionary. This would be out edges source destination dot add, or this is in edges dot add source. This would be the simple thing to do, but we want to, it may not be there yet. So we need to say if incoming edges dot try get value of our destination out, this would be a list of string edge list. Okay, so if we're able to get it, we could do edge list dot add range sources. We add all of those. Does it need to be a hash set? I don't know if it needs to be a hash set. So the new destination, this is going to be, am I doing this backwards? Smab, welcome back to the stream. Not all lines have a module type and just have a name. And hi, I just popped in. Not all lines have a module type and just have a name. And hi, not all module lines. Broadcaster's the only one that doesn't. I think I have this backwards. Spoof, I think you're right. Because this is the destinations. This is the source. Yeah. Destinations. This is where my brain was getting it. So I want to say for each string destination. Yeah, do an explicit check for broadcaster. For each in destinations. So each one of these, okay, yeah, I have it wrong here. Each one of these, I need to add in the source. So the simple thing to do would be if I had my incoming edges. Destination.add source. Yeah, each one of those needs to do this. I want to replace this with my edge list. Do you know that there's a destination node that's not source, so it's not in your source list? There's a destination node, not in a source node. We're gonna do list string edge list is this, but we can't quite do that. We got to do a try. If incoming edges dot try get value our destination out list string edge list, we're going to say if it's not, if we couldn't get it, we're going to create a new edge list, and then we're going to add it into our dictionary. Incoming edges of destination is equal to edge list, like that. Okay, so I believe this will add the incoming edges here. Do note that there is a destination node that's not a source node. There is a destination That is not a source. When I build this thing up here, there's a destination here that's not a source. Every time one node goes nowhere. Okay, one node goes nowhere, you're saying. A goes to imcon, B, inv, con goes to output. Oh man. Okay. Well, thank you for that. I typed source 3 sometime before. When you accidentally typed source 3 a minute ago and corrected it, made me wonder with all the just because programmers out there, has someone written one that uses leet speak to make your code look even more like Movie Hacker? I'm sure they have. Okay, so there are the problem. Let me think. Do I catch this? Do I catch this real quick? I haven't had time to look, Tuber Tugger. I've been crazy busy. And Jormunder, welcome back to the stream. It's nice to see you here. Tuber Tugger, welcome back as well. I did accept it. I haven't looked at all. I've been too busy with admin of code and everything. It's gonna find our destination node here. Our out edges will have it here. I just don't make an actual module for it. What type is this output? Let's read the example here. Here's more interesting. This module configuration includes broadcaster, 2 flip-flops, a single conjunction, a multi-conjunction named con, and an untyped module named output for testing purposes. The multi-input conjunction module, con watches the 2 flip-flop module, and if they are both on, sends a low pulse to the output module. Okay. Here's what happens if you push the button once. Both flip-flops turn on and a low pulse send out the output. However, now that both flip-flops are on, so this is just a sync, like it just absorbs things. All right, so we have a type called, what is it? What, you know, sync, is it SINK sync for like something that absorbs everything? SINK equals, I'm just gonna give it an asterisk for a sync. That's really annoying. That's really annoying. What I can do string module, we have a sync node. All right, so module type dot sync pulse, or don't care, just returns empty, comma. There we go. So a sync just returns nothing. It does nothing. It does nothing. It says there, it doesn't do any pulsing. Right? It just absorbs. So it only sends a high pulse to output. Okay. What we can do is when we go to get a module, we can just say that if it's not in there, it's a sync. I think that's what I'll do. Because the only time I'm really ever going to do nodes here is when I'm processing. I need to have like a push method. Okay, I think I parsed it in here. Well, we'll make it work. Well, I think we can make this work. In my actual input, do I have... Are there sinks in my actual input? Or is it just this sample input? Well, we'll find out. I guess we'll find out. Okay. There's one sink. Okay. Well, we'll figure it out. We'll figure it out. I'm not too worried about it. I guess technically that's a little bit of a spoiler, but that's okay. It's okay. I appreciate it. I appreciate it. Okay, I think we have this set up here. For parsing. I've written a lot of code here. I want to make sure when I parse. All right, let's test a parse here. I don't think it needs to be in there. I think I'm okay with it. Public void test parse sample input 1 fact, and we'll get a network in here. Module network dot parse sample input 1 module network. So a theory is multiple tests and it's parameterized. A fact is a single test that's not parameterized. So I can pass in the parameters here to the test. So for example, this ends up being 2 tests, one with sample input 1, one with sample input 2, and then 2 different expected outputs. Mizzard, welcome back to the stream. Thank you for submitting your solution. All right, so we have a network here, and network dot nodes dot contain should contain keys. Should contain key. Broadcaster, A, B, C, and INV. Broadcaster, A, B, C. Just some sanity check and INV. Network dot nodes dot count dot should be 5. And then let's just make sure each one of these, let's do a quick sanity check. Network nodes, incoming edges of A dot should contain broadcaster. And INV. A dot count should be 2. Network dot incoming edges of B dot count 1, 2. Network dot incoming edges of B dot should contain. Oh, thank you. Should be 2. Thank you very much. should contain broadcaster and a broadcaster. I think there's a way to do multiple things here as well. I'm just not familiar with it. Thank you for the lurk. Enjoy your time lurking. Smab and Spoof. Yeah, I don't should contain. There's not a should contain all. There's like a should satisfy all. Yeah, I feel like I've done it before, but it might have been something that I wrote. Network, not incoming edges. C, not count. Let me pull this down. This is just a sanity check. Count. That should be 1, 2. Woof. Should be, should contain broadcaster and B. And then lastly, we got inv. Inv appears on the right side once. Should contain C. Okay. I feel relatively confident. Let's do network nodes of A dot m type dot should be new. There's going to be problems with that. M type dot should be flip flop. Should be conjunction, and then this one should be broadcaster. All right, let's test this thing. Sanity check. Thank you for bearing with me on this. This is... Hopefully I don't have an infinite loop in my parse. I shouldn't, because I iterate through all of them. All right, we got a index out of bounds. That's interesting. Replace on trim split. New environment dot new line. Okay. A should be 2 but was 1. Let's try one more thing. Trim. Remove. Empty. Just A is on the 2 times. 2 times. It's failing. Okay, so I have a bug in my parse. Let's put a break here. Just take a real quick peek here. Step over, step over. The first row should be our broadcast. Put a breakpoint here. Should be subset of. Thank you, Spoof. Should be. There's a should be. You can look at that real quick. I'm about to ruin everything here. Should be subset of. And then I can give it expected. I like that. Thank you, Spoof. I'm not gonna fix it right now. I'm right in the middle. My broadcaster. So it detects that it's a broadcaster. Oh, I don't add. Okay, right here I missed my network. Dot add incoming edges for broadcaster destinations. I have this code repeated, which I don't quite like. Here, can I just do... There's probably something I could do to fix that. Gotcha. That would make sense. I didn't care about the order. Okay, so my parse is... I have confidence. I'm not saying it's correct. I have confidence that it is doing something well. That it is mostly correct. Okay. So now I need to do a push button. And our network here, we can track some stuff. Public void push button. It's going to do the whole loop, the whole propagation through. And I need to keep track of public int low count, public int high count. Count the number of low pulses and high pulses. Phil says mine is boatload of console logs. Yeah, so this is... It lets me make sure I don't break anything later. The first like 5 days I didn't do it, and then I was like, okay, I want to be able to retest these things. If I change something here, I still want to make sure it passes. It's not quite test driven, right? I don't do all tests first. I wrote this and was like, okay, sanity check. If this was shorter, I probably wouldn't have done it, but I wasn't convinced that I had it right, and this saved me here because I was going to do something here. There's a little bit here that is repeated. These 3 lines of code are essentially repeated, and I don't like that with my implementation, but I could come back. But our push button here basically is going to find network. We're going to get we have a queue of pulses. So we're going to end up with a queue of pulses here. We're going to do pulses.enqueue range. Is there an enqueue all? Enqueue. There's not I want to enqueue a bunch of things. I'm a little annoyed that I can't do that. I need to go to my nodes broadcaster and then do a handle pulse low. Of false. Handle pulse. Hang on. What am I doing wrong here? If I'm a broadcaster, oh, I have like an incoming pulse. All right, so a new pulse, low, false, and then essentially nothing here. It ignores those, right? And I could say like string dot empty, and maybe I'll go up to my pulse class here, and I'll do a public static pulse empty, or like, you know, broadcast pulse is equal to a new pulse low, the source. Oh, I can't quite do that. Oh, this is like the incoming source. It doesn't care. I'm gonna get rid of that. McNets, welcome back to the stream. How you doing, buddy? Handle pulse. I just want to make sure we don't use pulse on the right side. Let me do a don't care here. Yeah. We don't care about the pulse on the right side, so it can be anything. Okay. I have a missing semicolon. Enjoy your day, G. Have a beautiful day. We'll see you next time, my friend. Have a beautiful Wednesday. Hope to see you tomorrow. We'll be back for day 21. We'll be back for day 21 tomorrow. But enjoy your day, and thank you so much for hanging out. McNets, how you been, my friend? It's nice to see you. This gets us back an IEnumerable of pulse here. Pulses. Initial. I want to do pulses.enqueue. I can't pass in. I want an enqueue all. Let's do a public static class helpers. You're working, isn't that boring? A little bit. Enqueue all. Depends on what you're working on, McNets. That's really what it comes down. Q of T. Hang on. T. Q. For each IEnumerable T to enqueue. For each T to L into enqueue. Q.enqueue. Public static. JD, welcome back to the stream. What have you been up to, my friend? Nice to see you. Thank you for being 7th to say first. You haven't had time to solve the last 2 days. Yeah, they're getting spicy. They're getting spicy, so they're a little bit trickier to do. Also, folks, we got a legend with us, JD, the incredibly talented JD.
You want to feel like you're talking with Captain. Let me see if I could do my Captain impression. I am not the Captain, but my eyebrows also move in a way like the Captain.
Thank you for the impression, JD. So, folks, if the Captain's not on, but JD's on, and you want someone to act like the Captain, go check out JD. JD, thank you so much for popping in, folks. Give that heart a click if you don't already love JD. Give him a chance. Everybody deserves a chance, especially JD, because it's worth it. It's worth it. Okay, so I just want an enqueue all here. Why can't I do this? Oh, because it's not spelled that way. Initial. Right, so we enqueue all of these, and we're gonna say, well, pulses try dequeue out pulse outgoing. Okay. Question mark here. Okay. Sometimes he uses his dog's shampoo. Do you use your Ridge Raider? Welcome back as well. Do you use your dog's shampoo? But when I do, I feel like such a good boy. Coding Chemist, welcome back to the stream. I love that alliteration. Coding Chemist. What a beautiful name. Coding Chemist, happy to have you here on this beautiful day. Hope you're having a beautiful day, my friend. Thank you for popping in. What have you been up to, Coding Chemist? And JD, what have you been doing on your stream? I haven't seen you in a while. Avon and Co been wearing me down. My end of the school year been wearing me down. I was closing out a last house, wearing me down. I'm just getting ground up into powder, fine dust, if you will. All right, so outgoing here, we're gonna say, we need to add in here. So we're gonna say high count plus equals outgoing, outgoing dot is high, 1 or 0. And low count 0, 1. All right, so we increase our high count or low count appropriately to count the number of pulses. I got follow botted Monday and ended up clearing out all my fake follows. Turns out I'm not even close to 1,000. Oh, bummer. Yeah, getting follow botted is wild, my friend. It's only happened to me, I think, a couple times, but I usually just report it. It's pretty easy to report, or there's tools that can do it. Did you use, what tool did you use to get rid of them? I forget what it's called. It's like, there's a couple different ones. Speaking of getting followed, Ayaka cutie, I have you met Ayaka. Ayaka Cutie is here to stay. I hope you know. Thank you for following. You're such a cutie. Ayaka Cutie. Welcome to the stream. Happy Wednesday. Hope you have a beautiful day. Ayaka Cutie. I feel like that is trying to get me to say like see more butts. I yak a cutie. And now I'm just saying it over and over. And so if there's something in there that I'm not getting, someone help me out. Or maybe it's just a great name. Happy Wednesday. Nice to have you here. Because I'm not sure yakking is a thing. What is a yakky? If I were to yak, I yacked a dollar. I don't know. Yak, I'm not sure. I'm so sorry, but welcome to the stream. I hope you have a beautiful day. Okay. High count, low count. Commander roots follow remover and filtered by known bots and timestamps. Gotcha. Commander root. High count, low count. Then we want to do our destinations. All right, so we have pulse dot outgoing dot destination, right? So we need to get the module. So we do node destination. And this is where the part where when we have a sync, we're going to crash. A sync is going to crash us. Dot handle pulse outgoing. Here. And then we just do pulses dot enqueue all of these. And then we just loop here. I'm pretty sure this is one button push. Ayaka. Yeah. Look, I don't know how pronunciation works. Yakking refers to throwing up. Yakking refers to throwing up. I think I've heard that. So we do one button push here, and this will happen. If I didn't want to keep track of all the low counts, high counts, I could also do this. Int, make it a little bit more testable. Int low count, int, make it longs. We're gonna end up needing longs probably. Low, long, high. And we can do int low equals 0, int high equals 0, high, low, and then return low, high. And we can test this here. Just give a sanity check because we know one push produce 8 low pulses and 4 high for our first input. All right, so we're gonna write a test here. Public void. Hang on. In the second one, after pushing a button 1,000 times, they don't tell us what it is for the second one when we push it once, so that's okay. Public void test push button. Fact. All right, and we'll do a not public. Module network is equal to module network dot parse. Did I? Thank you. Look, my brain defaults to ints. Yes, Nick, it's hilarious. You are correct. Sample input 1, network dot push button. Int low or dot should be 8, 4. So we should have 4 low pulses and 8 low pulses, 4 high pulses when we push the button. It's gonna crash on this on our sample too. Come on. All right. So sanity check. Sanity checks out. So module network equals module network dot parse inputs. count, we push it 1,000 times. For can we do this? No. Oh yeah. Here, watch this. Enumerable. No. Enumerable dot range. Or is there a dot count? Enumerable. Assuming that contains elements to be counted. All right, no. Enumerable dot repeat. I want 1,000 here. The element to repeat doesn't matter because we're gonna do a select on network.push, and this is gonna give us back. So I wonder, is there like a don't care thing I can put here? We're gonna push the button 1,000 times. And then we're gonna sum up the lows and highs. Dot sum. We have int low. Can we just do a sum on a pair? Is that a thing we can do? I don't think it is. P0, P1 goes to P0, P1 goes to 0. What can sum take in a function? Reduce? I could do an aggregate. It's called aggregate in C#. I want to sum. I could do an aggregate like this, which this does P0 HL0 or low high 0, low high 1 goes to low high 0 dot low plus low high 1 dot low, low high 0 dot high, and plus low high 1 dot high. Could do that. What does it seed it with? It's just the first element there. I could do this. Which is okay. And then this will be a long, two longs. Long lows, long highs. I could do this. Aggregate is fold. Spoof. Aggregate is fold. Sebastian, hey, I want to say thank you for the stream. At the beginning, I was a little confused of the challenge, but I've gotten some understanding while watching you trying to solve it. You have a great ability to explain. I'm glad you enjoyed it. I'm really close to part 1, I think, Uncle Scientist. And then we multiply them together, right? Aggregate forces that accumulate to have the same type as the enumerator, though. No, so there's different versions of aggregate. It takes in a function. It doesn't have to. You can do a T source and T accumulator. So no, it doesn't. Yeah. So, but this version, because of yeah. All right. So we just multiply these to get lows times highs. Is that what we do? Multiply them together. All right. It's gonna crash on. Keep in mind, the sync. I haven't accounted for push button. I haven't accounted for our sync. Because we pull it out right here. So hang on, let's do that. We'll do a module. Is that what it's called? Module. A destination. Is equal to nodes. Outgoing dot destination. Okay. This could be a thing that doesn't exist. So I want to do get value or default get value or default on destination. Sorry, outgoing.destination. Outgoing. Why are you auto-completing so far? And Uncle Scientist, how the heck have you been? Folks, if you want to see another incredible, I'm about to say another incredible developer. If you want to see, you want to see another developer who's incredible, because I'm not an incredible developer, go check out Uncle Scientist. How have you been faring so far? I think you're sort of towards the top on our leaderboard, Uncle Scientist. Go check him out. We're going to get a new module here that, is, well, hang on. We could actually do if nodes.tryGetValue instead. Because I'm just going to ignore it. We still add it up, but then we ignore it. Out module. Okay, so if should be module. And I'm going to rename this to target module. Okay. Okay, so we get the pulses, gets us some stuff here. All right. Hold on. Let's see if we have an infinite loop, folks. We don't. What do we get back? Okay, so we have something incorrect here, which is disappointing. So try is a... Anytime you see a try, the convention, and people do crazy things with these outs that we need to avoid doing. But what try methods return a Boolean and return true on success and false on failure. So it allows you to not use a it's often used for parsing, and it allows you to avoid exception handling where you explicitly try catch stuff. So in a lot of cases, it ends up wrapping a try catch, or in this case, there's going to be it's a little bit faster than checking to see if we contain it first. It's a compensation for missing some types? Possibly. I think I need to step through. So there's something interesting here. It's surprising. It's surprising that it fails for part 1 because this sanity check, if I do 8 times 1,000, 4 times 1,000, at the end of the day, I need to know what I'm getting out here. So I've done. Let's take a look at what my lows and highs are. Cirx Goko. Let me know if I'm pronouncing that correctly. Cirx Goko. We got you following me today. Oh, Cirx Goko. Thank you so much. I got Cirx Goko. Thank you so much. Thank you for following me. Thank you, Cirx Goko, for the follow. Welcome aboard. Welcome to Captain Coder's Academy. It's true, we still do have regular try catch finally. It's just, it's a little bit nicer to use the try in a lot of games. And also, the try, when we do this try here, it is actually, when we do the try, it's more efficient than doing it's typically, not always, it gives us the ability, because internally, the implementation, I know for sure here, try get value is more efficient than doing an incoming edges dot contains destination. So if you were to write this code, if it contains it, then do it. So then you would do incoming edges of destination. Technically, we have to do two accesses if we do it this way. So it only has to look it up once if you do it this way. So it's an implementation detail, but it's a little bit faster. You added logging, gotcha. I think my signals are okay. My flip-flops may not be doing the right thing. I want to make sure if I call push button twice. So here's the sanity check. If I call it twice, do I get 8-4 again? And I'm expecting this to fail. If I don't get 8-4 again, my something in my logic is messed up. Okay, so I'm getting 9 and 4 on the second one, which is interesting. Likely means something didn't get reset here. So I should be able to, let's add a debug. Probably counting the button broadcast signal. Should we not count the button? We don't, I think we're supposed to. My guess is one of these nodes internally isn't flipping right. So I gotta look in here. I gotta look in here and see which one's not working. Science, welcome back to the stream. Balint, how you doing, buddy? Welcome to the stream, folks. If you guys don't know Science, be sure to give Science a follow. Incredible educator, incredibly talented streamer, handsome man. I just can't get enough of you. I'm doing well, my friend. I'm doing my well, folks. Be sure to give Science a follow. We love him. We're working on admin of code. I got a bug in here. That we got to figure out what's going on here. So I'm going to add in a debug here on my push button, and I'm going to debug push button just to go look in here. My guess, Nick, is that something with my flip-flop, so there's a state thing that's going on here. So what I want to do is, let me go down here. I'm going to continue to the end, and I want to go look at my nodes. So these should all, if we've done things correctly, my A is still on. This is what I was expecting. I was thinking one of these things was going to be still on somewhere. So what I believe is at the end of the day, these are all supposed to be off, according to the write-up. Okay, so in the write-up it says, if the first of the same thing happens every push, 8 low pulses, 4 high pulses. I think it's saying after we run it, after this sequence, the flip-flop modules will all end up off. So pushing the button again repeats the same sequence. So my nodes here, my A didn't get turned off. And so I just need to step through this and say, okay, well, what's happening at each step here? So I'm going to come in here. We're going to say when we start dequeuing these things, first time viewer, Sunset Keck. Sunsets, welcome. Welcome, Sunsets. Welcome to the stream, my friend. Trayank says the button to broadcast counts as 1. Yes. Did you make sure conjunction knows all inputs up front? That was my major thinking. I can add them as sense. It does. So I build up my whole network of out edges and incoming edges first. So I don't think that's an issue. But we're going to find out. We're going to step through one at a time. But Sunset, I hope you're having a beautiful day. Welcome to Captain Code Academy. Happy Wednesday, my friends. Let's do a debug here. We're working, since you're new here, we are working on admin code this December. I don't know if you're familiar with Advent of Code, but it's a series of puzzles. We're on day 20. Every day we get a new puzzle. Each puzzle has 2 parts. Yeah. All right, folks. I haven't done this. Look, anyone who's new here, I am Captain Coder. Captain Coder is me. And me is a computer science educator. I teach. My full-time job is to teach computer science and programming at a school for ages 10 to 14. I get to do that all the time. It's my dream job. I absolutely love it. I have so much fun doing it. In my free time, I like to do wake up and code here. So we wake up, we're programming. We're programming here. Outside of Advent of Code, I usually do data structures and algorithms. So we do lessons where we do data structures and algorithms. Where we cover some data structure, some algorithm. We do a little bit of game dev. We do actually a lot of game dev. Do game dev. I'm making a game called the Poorly Drawn Game. I also do, what else do I do? We do some collab streams. I teach lessons, so people will join me on stream and I'll teach lessons to them. And then we do showcase where people show stuff off. Yeah, so nice to have you. It failed for me because it checked for all high, but I didn't know B, which was low, and incorrectly sent low. So we'll find out what's going on here. We're about to step in here. But yeah, it's my full-time job. I love doing it. I get to teach young people. We'll hit continue here. All right, so we should pulled out pulse contains 2. We're about to pulse A. We're about to pulse A with a low. Okay, so pulse A with a low. After this, we should pulse A. So right now, let me pull this in here. All right. We are doing this sequence of events. Hope this doesn't mess up my debug. This is a sequence of events I'm hoping to have here. All right. We did this. Oh, I'm not counting this. Are we supposed to count this? You know what? I'm not actually counting this. I prefer this over an if statement, Nick. I do prefer this over an if statement. All right, let's run our debug one more time because we got everything botched here with that. Oh, I just commented this out. That was going on. Okay. So before we start, here, I want to see what our initial is because I don't count this low. 1, 2, 3, 4, 5, 6, 7. Yeah, notice I'm not actually counting that low. Low should start at 1. Because we do one pulse here. So something is not correct. Someone correct me if I'm wrong. Someone correct me if I'm wrong. You cue the button and it counts the cue, no? No, I don't cue the button. I just call, I get the broadcaster and I handle the pulse. So I think low needs to start at 1 because I'm not handling that. Mary Kate says, Mary Cat, sweet. Just got to the challenge page, joined your Discord. Welcome to the Discord. I've been following you for a while, get the notifications, but never get a chance to see you. Irish John recommended you recently for teaching, learning. I was like, I know that guy. Well, I'm glad you're here. I've been learning stuff online for 87 days. Nice. Yeah, so I need to count low here. So there's definitely something wrong with what's going on here. Let's follow this through. Let's follow this too. I'm gonna debug this test one more time. Snabble, welcome back. Let's hear your bad pun. Let's hear your bad pun. I'm looking forward to it. Let's hear it. No, I don't fake it there. Maybe that would be good too, but yeah. My cue, so if I step over this, my cue right now should be lows to A, B, and C. Low to A, low to B, low to C. Okay, so that's my current queue is this. And we're about to consume this one. We're about to consume it. Which Muppet is the best coder? Kermit. He commits a lot of code. Snabble, thank you for the pun. Thank you for the pun. Points and Snabble. 50 points. Nice, my friend. I feel like you should print the nodes as you pop the queue and compare when the expected sequence. I could do that. I might do that. I think I'm going to step through these here to make sure as I come in, my low becomes 2. So I just did this. So I have 2 lows. And now I'm about to enqueue. I should enqueue A high B. A high B. So let's look at my pulses. A high B. So we enqueued that fine. We're going to dequeue the next one. Okay. So we should be doing low, broadcaster low B should be our pulse. Outgoing, broadcaster low B. Okay. That is correct. So low increases by 1. Step in here. And we should enqueue just B high C. B high C. Okay. I could do it. I could do it. We'll continue. So we should now be doing broadcaster low C. Broadcaster low C. Broadcaster low C. So we got 4 lows. We've done these 4. And when we add these in here, we should be adding in inv low A. Sorry, C high inv. So we have these 3 left. A, B, C. Okay. Continue. We are now on A high B. A high B should just get absorbed. We should have nothing should get enqueued, so our queue should not change. Our queue didn't change. Our B, let me double check B here. Is still on. So it only flips if we get a low here. Okay. When I'm curious about this one. This one feels like we're not flipping properly. My gut is telling me right here when we get this low into A is not flipping properly. Or, so right now our A should be high. Nodes, A is on. Okay, so it's high. I'm going to continue. I think we're on this one now. So our outgoing inv, all right, source, C high inv. C high inv here. Okay. And this should queue in Q an inv low A. So we should now have inv low A. All of these should still be low. No, high. Because they got, so this low here should flip this one to false. So our target, A, high. After we pulse, we've gone to false. NPy A here. I'll risk, it might be easier to print. I don't have... All right. Since everyone wants me to print, we'll print. When I print, I don't have the ability to step in a little bit. Right line. We'll print since everyone's complaining. Since everyone's complaining here. Console dot right line. Outgoing dot source. Outgoing dot is high. High. Low. And then outgoing dot destination. And then I have a typo in here. There we go. Oh, it's not just you, Alrisk. Everyone keeps saying, just print it out, just print it out. And if I print it out, I'm not gonna. It's fine. It's fine. We'll see here. Print it out. I know. Alrisk, hey, welcome back to the stream, my friend. Happy to have you here on this beautiful day. Hope you're having a beautiful day. Now I gotta. So now I gotta write more code. Now I gotta write more code over here. Because I'm doing it through a test framework. So I essentially have to do this. I have to pull all this stuff over. It's because I don't have like a console app available. I have to write one now. All right. All right. CD implementation. I'm glad you enjoy it. All right, let's see. We'll compare here. All right, so it's like the internal state is what's going wrong here. Oh, low, load A, B, C, high, B, C, inf low A low B, C, inf. Oh, hang on. Okay. A low, B low, C low. Low. Hide imp low A low B, A low C, C low inv. Why would C ever go to? All right, C goes to inv. All right. This is why I didn't print, because it's hard for me to... My brain can't handle this. My brain can't handle it, so now I have to put it side by side. I was almost there anyway. You guys should have just let me go. Should have just let me do it. I'm joking, of course. I'm joking. I've already said that. I said I think the issue is in conjunction. I said that earlier, and I was almost there. Hang on. I copied the wrong line. I'm still doing it wrong here. D, I am inf, low A, A low B, B low C. Okay. Okay. We had a whole conversation about Uncle Scientist. Someone else already said that. Yeah, we have an extra line here. Because we added some pulses. So my inv seems to be incorrect here. All right, so let's go look at our conjunction. We have a last input, and we set it to whatever the pulse is. The incoming pulse, we update it. Then we get all of our incoming edges, and aha! We found it. We're saying that we're always true. We're always hot. All right, X. There. Am I just doing all? No. All true? No. That's right. All right. Let's try it. Okay. All right. We found the bug. Look, folks, I was almost there. If you didn't make me print it out, I was literally almost to the conjunction. I was going to step in and look at it, and I would have gotten here and said, like, no, that should have not come out that way. But I was printed out. Print line debugging. That's the best way to debug, everybody. Print line debugging. But no. All right. Let's say it's not a bug, it's a feature. All right. So, let's get our input. I haven't gotten my input yet. I wouldn't have gotten there if it wasn't for these pesky chatters. The chatter. All this chitter chatter. Pitter patter. Fitter fatter. Take our input. Let's put this in our test folder as well. Public read only string. To print out. No one said to print out. It was Captain Coder's idea. You're the one that wanted to print it out, Captain Coder. File dot read all text. Read all text, and then we'll write a public void test puzzle input 0 fact. Trying to make the stream go as long as possible. What you should be doing is trying to get me through it as fast as possible, because I have things to do today. Unfortunately, I have things I gotta do today. I gotta be done so I can go, because the things I was doing yesterday didn't get finished. All right, so let's see. Come on. Let's see here. This number. Folks, we need it on the first try. Ah, there we go. We want to keep you live. It's true. Keep us live. All right. All right, let me just bring Captain Coder Funko and make you slow down even more. Even more. All right, folks. We've been going way too long without a break. I only have about 20 minutes left, so I'm just gonna, let's get a commit in here. Git add. Let's go up a directory. The chore cam, I know. Feet implement day 20 part 1. All right, we're gonna go ahead and read part 2. I'm gonna give you my take. We'll take less than 5 minutes if you use print line debugging. Thanks, Uncle Scientist. I'm sure it will. All right, I always like to predict what's gonna happen in the next part before I read it. So we have built a DAG. All right, so we have a directed. Oh no, I don't know if we've actually made an acyclic graph. I don't know if we actually have a DAG. Well, we have some sinks in it. We have some sinks where we stop. I think we have cycles in here. We've created a directed graph. Interesting. Okay, so the puzzle asked me to press it 1,000 times. We have a graph. We're gonna have to do something special with the graph. My guess is that our state space is massive. My guess our state space is actually kind of massive with all the twiddling of flip-flops and whatnot. But my guess is they're going to ask us to push the button 10 billion times or something. Some enormous number of times. My guess is they're going to ask us to push the button some unrealistically unsolvable number of times. And that we have to compute like the on and off on it. So, because of this, we're going to have find a cycle in our node. So we have some state space where our nodes have like on and off. All the switches are on or off. And we have to find the cycle at which it repeats. So that way we can do it. Just push the button faster so that we can figure out what that number is. And we can short circuit by saying, okay, well, if I push the button 7,000 times, I get this many lows and highs. And then it's a cycle. And so I have to push it a bunch of times to get the end result. So that's my guess. Let's find out. Let's find out here. Part 2. The final machine responsible for moving the sand down to Island has a module attached named Rex. The machine turns on when a single low pulse is sent to Rex. Okay. Reset all modules to their default states, waiting for all pulses to be fully handed after each button press. What is the fewest number of button presses required to deliver a single low pulse to the module Rex? Okay. I'm assuming that I can't just do a while Rex has not gotten a pulse. Push the button until Rex gets a single low pulse. Oh no. We don't, oh geez. There's no sample puzzle here. I'm sure it's what's annoying here is they don't give you some sort of range. RX. All right, so let's look at. We have one RX here, and J. So we have. So this is a sink. All right, so RX is our sink. RX is our sink. So what are the, so now we got to say, what are the inputs to JM? So JM sends a low pulse if, I might need to print out my graph. I might need to write a thing that displays my graph and so I can look at it. All right, we're gonna do I have graph viz? Drop the squirrel in your off topic. Nick, we'll check it out. Hang on. I want to. I don't have graph viz. I want to. Is this graph viz format? All right. It might be mermaid. Graph viz online. I want to view my graph. I'm not sure this will actually work. I think I might have to do each one individually. Hang on. Let me figure out the syntax here. A goes to B. Okay. I'm gonna build. I want to visualize my graph. I want to visualize my graph real quick. And so I need to do the. And I think then I could do B goes to C. I want to visualize how these all talk to each other, but we have a special. So basically, I want to know. All right, I have RX is a single sync. JM is the only thing that goes into it. JM. All right, so we have JM has 4 things that go into it. So I want to, okay, so when all those 4 things have sent a low pulse, is that right? Or a high pulse? So if all of those have sent a high pulse, sunset, you won't until I solve it. I need to come up with a strategy. So if all of these have sent a high pulse, so when one of these sends a high pulse, if the rest of them have also sent a high pulse, then that's the end. That's the end. All right, let's see if we can write a visualization for this. Oh, that's our input. Input is equal to file.readAllText input.txt. We'll get our network, and then I want to print out my network. For each module M in network.nodes. These are our modules. I should rename that. What are you complaining about? Oh, it's a string. Nodes.values. We want to do for each string edge in network.outgoing edges of m.name. Console.writeLine m.name goes to edge. It's not edge, destination. Destination. .NET run graph.viz. Could not find input. Copy. input here. Okay. So there's our graph. Let's go to our graph visualizer. Aha! Okay, check it out. Check it out. I don't know if this is... So for my input, we have what appears to be JM goes into here. We have 4 DH here. It looks like DH, LM, SG. Looks like 2 sets of lungs. It looks like we kind of have DB, LM. It's a little bit tricky. My guess... Okay. So here we have some special nodes here. DH, LM, SG, and DB are like the nodes that we care about. There's only one node targeting RX Mizzard. So there's one node targeting RX. And then DB, LM, SG, and DH are all conjunctions. The only nodes that going into this one that's outside are these ones here. So it'll always send a high unless all 4 of these send a low at the same time. And then something that you can notice about these ones. Let me do one more thing in my output just so that I can... I want to have our type here. Care type is gonna be blank. We'll say if m dot type is flip flop, add an ff. We'll make this a string. Type equals flip flop. I think we have conjunction. Let me add in. Oh, we don't know the. This is. I can't quite do this easily. I can't do this the way I want to. Let's just eyeball it here. So I know that DH, LM, DB, and SG are conjunctions. What about QQ? QQ. Because these each have one going into it as well. BC goes into it. SG goes into it. LM goes to it. Hang on. Each one of those has exactly one. GJ. Eyeballing. GJ. GJ is a conjunction. That goes into that one. BC is a conjunction that goes into DH. QQ is also a conjunction. And then BX is going to be a conjunction. I'm almost certain of it. And BX. Yeah, so BX a conjunction. So my hypothesis is that there are 4 contained networks that have cycles based on this here. each lung, we have 2 pairs of lungs. I got 4 lungs. Each lung is going to have a cycle on it that will cause these here to fire off. Boom, boom, boom. And we're looking for when they line up. When they all line up, JM will fire a low signal when they all line up. So we want to find the cycle length of 5 minutes. Let's go. I know. I want to find the cycle length of DB, LM, SG, and DH. Okay, so I need to find the cycle length of those. This is such a hack. This is not, look, folks, I'm not writing a general solution here. This is such a hack. All right, so we're gonna parse this in here. And I want to know the cycle length of the following set. So I'm gonna have a dictionary of general solution and Captain Coder. we need general solution. General solution. So we have a dictionary int cycle length. Okay. Let's set this to new, like this. We're working on a major hack here, folks. All right, so we're gonna say, wow, cycle lengths.count is less than 4. We're gonna find the cycle lengths. Well, it's less than 4. Our targets here. String array targets. It's gonna be equal to DB LM SG and DH. All right. So we're gonna say when that one is a high. All right. So when that one is a high, we need to like call network not push button. Network.push button. Redston, ahoy! You're welcome, Redston. It's always fun to pop into your streams, folks. Redston Pro, Redston 4D, no longer Redston Pro. The artist formerly known as Redston Pro, streams game development, working on his game Wood, which is Doom upside down. If you take the word wood and you flip it, it's Doom. It's Doom. Look. Oh, Whoop. Sorry, I was wrong. Working on the game Whoop. If you flip that upside down, you get if you mirror it, you get Doom. Is that right? Did I get it right? Or is it poo? Is it poo? Oh, is it Cool. Mood. Look, I don't know. A Doom flipped 180 degrees. Okay, gotcha. I was close. All right, so we're going to push this button. And then we need to check. We need to check these things. And we're going to say, did a module just send a high? We need to know when one of these did it just send a high? We push the button. We know Doom, Quoo, Whoop, Moob. True fact, never been said. Toak, welcome back to the stream as well. I missed you a little bit earlier. I was deep in focus. We're out of time here, folks. I'm so close. I believe I'm so close. Push button here. I kind of want to say, look, we're going to do a Hail Mary here. We're going to say, for each string target in targets. I don't think I can do it this way, but I need to know, this thing just sent a network of target network dot nodes here, module m dot is on. This isn't right though. It's not is on. It's this isn't gonna work for us because it doesn't keep track of whether it is on or not. It's whether or not it just sent a thing. I'm so close here. I'm so close. I'm gonna write a dumb. I'm gonna do a dumb, folks. I'm gonna do a dumb. Public pulse last sent. No. Okay. Hold on! Grab onto your butts! I'm gonna do a dumb! We're gonna do the dumb! Alright, so... Last sent... Last sent... Last sent. They all start out as false, because what we care about is when we swap to true. So last sent here. You push the button. Last sent. For a conjunction, last sent equals all high. All right, we're gonna. I'm about to get things are getting crazy. All right, module m dot last sent. If last sent and cycle length does not contain cycle length does not contain target, contains key target, we're gonna do cycle length of target is equal to int pushes equals 0. Pushes. Okay. We're doing the dumb here. Console dot write line. Let's do a cycle length dot key. I want to get the key value pair of this. I want to print out the key value pairs of this. Let's do a debug here. There's no sample test. It's crazy. All right, puzzle inputs. Part 2. Let's add a breakpoint here. I want to look at you can get an infinite loop and pushes less than 1,000,000. All right, hopefully we get our cycles in less than 1,000,000 pushes. Let's go with 10 million. All right. Let's run this in debug. I think 10 million is .NET. No, I don't. .NET test. I just want to make sure my test eventually exit. If I click run here, it may just never exit. And I'd be in a bad... If I have an infinite loop... Oh no. Do 1,000,000. Oh my goodness. Pushing that button takes a while. Oh, I don't think I have... I think I'm going down a bad path. It must be expensive to push that button. Okay. All right, we're gonna have to do. All right, I don't think I have a winning strategy. I broke my part. I broke part 1. I broke part 1 as well by doing this. I gotta get out of here, folks. I feel so close. I'm on the right track? Okay. Why does this just not build? I accidentally broke my test by adding in last scene. It must... Oh, this is getting recalculated? Or something? That doesn't make sense. Or did I just copy and paste the wrong thing in here? What was my answer for part 1? What did I broke? I broke part 1. What did I do? Sorry, folks, you're watching me experience my changes. The only thing I've added is that, and that. Which is not making sense to me. Oh, did I modify my test? No. What? It's okay, Redston. I don't have any idea what's happening either. It makes 2 of us. Why is my puzzle broken? I did nothing. Hang on. Get... Stash. Alright, we're gonna stash. So it should be back at my commit. Did I break my input file somehow? Okay. So I'm lost as to why this is failing. Maybe I might have accidentally touched my input file and broken it. All right, let's go to my input file here. All right, I accidentally modified my input file. That's what happened. All right, so I broke my input file. All right, let's do a get stash pop. All right. Make sure. We'll do a refresh on that. I'm running late. I'm running so late, but I gotta do this thing. All right. Don't modify your input file. Of course your test will break. Okay. Test. Should get 1 failure. It should be on this one, and it shouldn't be an infinite loop. Okay. Let's debug this test. Which should... Did I add any breakpoints? I did not. Stop. Breakpoint, debug, part 2. And hopefully 10,000 pushes is enough. All right. We should get rid of you. All right. Pushes is 10,000. All right. 10,000 was not enough. Let's do 100,000. Cycle lengths dot count. Oh no. Okay, we can do that. We can do 100,000 counts. I bet modifying my my input made an, like a weird infinite loop or something, so it wasn't actually cycling these. All right. Debug, come on. When I get low on time, I start getting a little bit frantic, and then my brain doesn't work, and so nothing is working. Everything's working. No. Oh no! Have we find a cycle for any of them? We haven't found a cycle for any of them. Oh man. Last sent. Am I actually setting this? Hang on. Last sent is if they're all high. If they're all high, we send a low. I'm looking for. Hang on. I'm looking for when we send. When it sends a high signal, right? Yeah, because all of them have to send a high signal. So I want to find when it first sends. Okay. Do we do 1,000,000 iterations? Oh my goodness. Million iteration takes a really long time to run. I think I need to modify. Okay, it will eventually finish, but it's almost certainly not stopping early. Do we get any of these? Reach target. I'm gonna have to go, guys. I'm sorry. I'm gonna have to finish it offline. Bummer. Just keep checking the cycle links for 4. I don't understand your assert false to kill the test. I don't understand your suggestion. Sorry. Why didn't it hit this breakpoint? Come on. Great. There's something stuck in there. All right, folks. We hit an issue with .NET clobbering a file And I have to like kill .NET and stuff to get it to work. All right, I think I need to go. Yeah, this is why I don't like to run it here. If I have a chance of an infinite loop, there's an infinite loop running, and it doesn't know how to end. Yeah, it's busy reading something. All right, I gotta go anyway. I'm 15 minutes late. I gotta hop off here. Thank you guys so much for hanging out. I'm gonna finish this off stream, or maybe no, I'm not gonna be back on streaming because I'm gonna be gone all day. I'm gonna be gone all day. We're gonna try to solve it off stream. I think I have, and people have kind of confirmed that I have a good strategy here. There's some sort of cycle going on. I don't think I can detect it here for some reason. I don't understand why. Find the cycle links, figure out where they intersect. So there's gonna be like an LC. Oh, the debug just stopped. Yeah, a million iterations. I'm not finding any of these. Yeah. All right. All right. Have a beautiful day, everyone. I'm frustrated because I can't figure it out. We're gonna raid someone. Any suggestions? If you have any suggestions, let me know. Otherwise, we're gonna find someone. Quick, I'm super late here. Anyone I know doing admin of code? Twak, thank you so much for hanging out. It's been wonderful. We got the first part. I don't know what's going on here. We're gonna raid. I don't see anyone I know doing admin of code. Advent of code. One up time. Let's see if one up time is in English. One up time's doing day 20. All right, folks, we're gonna go raid one up time. They're programming in Rust. All right, everybody, have a beautiful day. Thanks for hanging out. Remember to keep coding, keep growing. Sorry, keep coding, keep growing. Be the best you can be. You're welcome back anytime, and we'll see you tomorrow for day 21. Day 21. We'll be back tomorrow. Have a beautiful day, everybody. Bye-bye.